So today we're going to be talking about solving systems of equations. Now this whole section is going to take us a couple of days. We're going to learn how you can solve them by using a table, by a graph, and by algebraic methods. And so first of all, we're just going to define something known as the break-even point. The break-even point is a point at which income equals cost. It's a point at which income equals cost. And so basically what companies like to do is they like to figure out where their break-even point is, because at which point after they hit the break-even point, they start making money. And so your book actually has an example of this in the start of this section, which is on page 136, and it talks about mowing the lawn and a lawn mowing example. And so if you want to go read that, that's fine. But what we're going to do is we're going to go ahead and jump into an example. Now if you remember Friday, we used GeoGebra. And we graphed two lines, and then we found what? Where they intersected. Okay, we're going to be doing that same thing today, except for it's not going to be as easy because now you're going to do things manually. What? So let's go ahead and look at the first one. The first one is, it says solve the system of equations by using a table. And so what we're going to do, if you remember from Friday, what you would do is you would type those into GeoGebra and you would find their intersection point. We're going to be finding their intersection point here as well, except for we're going to be using a table to do this. So one way to do this, okay, is to first of all solve each equation for y. So let's solve the top equation for y. And when I do that, I have 3x plus 2y equals -2. How would I solve that for y? How would I solve? What would be the very first step I would do to solve that for y?
The 0, 0 thing.
Put a 0 in.
Yeah.
How about we subtract 3x?
Okay, that works.
So then I end up having 2y equals -2 minus 3x. What do you do now to solve that for y? Divide by 2. So we end up getting y to equal -2 minus 3x all over 2. So that's the first one. Now what we're going to do is do the exact same thing with this one. -4x plus 5y equals -28. What's the first thing that you do?
Add 4x.
Add 4x to both sides. So I get 5y to equal -28 plus 4x. Or I could write it this way, 4x minus 28. And then last but not least, what do you do? Divide by 5. So I get y to equal 4x minus 28 divided by 5.
Wait, no.
So now what I'm going to do is I'm just going to pick values for x. So a good rule of thumb is to start with 0. So if I start with 0, what I'm going to do now is I'm going to take 0 and I'm going to plug it into the green equation here. All right? So if I plug 0 in for x, what do you get?
1.
-2 minus 0 over 2.
-1.
Which comes out to be -1. Now what I'm going to do is I'm going to do the same thing with the pink equation. I'm going to plug 0 into the pink equation. So I'm going to plug it in here. So that comes out to be -28 over 5. Do those match? No, so that is not our solution. So I need to pick another number. So another number after 0 would be 1. So I'm going to go through the same process again. I'm going to plug in 1 right here. So I end up getting -2 minus what?
-3.
-2 minus 3 over 2. What does that come out to be?
That would be -5 over 2.
-5 over 2. I'm going to do the same thing. I'm going to plug 1 in here. So I get 4 minus 28.
-24.
-24 over 5. Do those match? No, so I'm going to try another value. So let's go ahead and try 2. So let's plug in 2. So I'm going to plug in 2 up here. So I end up getting -2 minus what?
6.
6 over 2, which is what?
Negative 8 over 2, which is negative 4.
Negative 4. Let's plug in 2 over here. So what's 4 times 2?
8.
Minus 28
Negative 20.
over 5?
4.
Negative 4. Oh,
Okay.
so what is our solution?
Negative 4.
2.
The solution is 2, negative 4. So just as in GeoGebra, when you went ahead and plotted those, the solution was a point. The solution here is a point. Now, I will tell you, solving for y from the onset takes a little bit more time. You don't always have to solve for y, and that's going to be what we look at in the next example. Okay, in the next example, what I'm going to do is I'm just going to leave it as it is, and then you can choose which one you want to do on your homework. It doesn't matter. So on this one, what I'm going to do is I'm just going to start by plugging in values. So I'm going to start with 0. So all I'm going to do is plug in 0 in the top equation. So if I plug in 0 in the top equation, I end up getting negative 5y equals 11. So what does y equal when you divide by negative 5? Negative 11 fifths. Yep. So now I'm going to do the same thing. I'm going to plug in 0 in the bottom equation. Oops, that doesn't look like a 0, but it is. So I end up getting 4y to equal negative 13. So what does y equal? Negative 13 fourths. Do those match? No, so I'm going to pick another value. Let's pick 1. Once again, I'm going to plug in 1 to the equation. Now, when you start dealing with the numbers now, it's going to start getting a little bit more tedious. It's not going to be as quick as it was on the first slide. So on this one, I end up getting 2 minus 5y equals 11. So what do you have to do now? Subtract 2. Good. So you get negative 5y equals 9. So what does y equal? Negative 9 fifths. So now I'm going to do the same thing on the second equation. So I end up getting negative 3 plus 4y equals negative 13. What do you do there? Add 3. And so I end up getting 4y to equal negative 10. And what do you end up getting? Negative what? Yes? He left. So I end up getting what? Negative 10 divided by what? 4. So my answer is negative 10 fourths. Do those match? No. So I need you to go ahead and find number 2. If you plug in 2, I need you to find what values do you get. So go ahead and plug in 2 to each of the equations. So what did you get your first solution to be? Negative 7 fifths. Did anybody do the second equation? 7 fourths. Okay, so then we got to try what number next? 3. Let's try 3 and see what we come up with. Okay, so go ahead and plug 3 in now. So what did you get for your first solution here?
Negative 1.
Negative 1. What about for the second one?
Negative 1.
Negative 1. So your solution then to this system of equations is 3, negative 1. So you can see the difference between how we solved this system and the previous one before. For some of you that struggle with solving the equations, you might want to go back and solve for y first, because it is a little easier to plug the x values in, but you don't have to. Okay, so now what's going to happen is we're going to look at how you solve it by graphing. Now if you get out that gold sheet I gave you with the equations on it, I need you to look at the top row. The top row where it says a standard form of the equation of a line. Now the neat thing about this is if you look at the characteristics column, it says if an equation is in standard form, ax plus by equals c. So in this case, a is 2. What is b? B is -1, and what c is -1. And so now if you look at what that sheet says, it says that the slope is defined as being negative a over b. So in this case, the slope of this line will be -2 over -1. That simplifies to be 2. So by using this, you're going to save a lot of time. The only other way to find the slope and the y-intercept would have been to put this in slope-intercept form. And that's going to take some time like it did on the first slide. And so now, according to your gold sheet, the y-intercept is defined as being c over b. So what is c in this problem? -1 divided by b, which is, so your y-intercept is 1. So I'm going to come down here and put a dot at 1. The slope of 2 means you do what from this point? Up 2 over 1. Up 2 over 1. Next, what I'm going to go ahead and do is I'm going to go ahead and draw a line in. And I'm going to go through those points. So there you go. Now what we're going to do is we're going to do that same thing with the second equation. However, notice the second equation isn't quite written in standard form. What I need to do to write it in standard form is switch the x's and the y's. So let's find the slope. Slope is -a over b. So I've got my negative sign. What is a?
5.
5 divided by?
Negative square plus 2 positive.
Divide by 2. So my slope is -5/2. Your y-intercept is c over b. So what is c? -16 divided by,
-8.
which is -8. So that means I'm going to come down here to -8. So 1, 2, 3, 4, 5, 6, 7, 8. Now slope of -5/2 means that you go down 5 and over 2, to the right 2. What's another way from this point I can do a slope of -5/2? Up 5 and to the left 2. Oh, look at that. So that's where they intersect. So like GeoGebra, I need to give the coordinates of that point. What are the coordinates of that point going to be? -2, -3, and so that is your solution, and you're done. Now, it's not always going to be that case where you're able to draw your dot right to that point. You might have to draw your lines in and just see where they intersect. Let's go ahead and look at another one. Okay, x minus 2y equals 0 and x plus y equals 6. So let's try to find our slope. So what's our slope going to be here?
X 1 over -2.
-1 over,
Why would it be -1?
because it's -a
Oh, right.
over b. So my slope is 1/2. What is the y-intercept going to be?
0.
0 over -2, which is 0. So y-intercept of 0, 1/2 means you go up 1 over 2. So what I need to do now is go ahead and draw my line in. And then let's go ahead and look at the next one. What's my slope of my next line going to be? -1 over 1, which is -1. What's the y-intercept going to be? 6 over 1, which is 6. So 1, 2, 3, 4, 5, 6. And then slope of -1 means you do what? Down 1 over 1. So I need to go ahead and draw my line in. And so if I draw my line in, I can see that they do in fact intersect. And what point do they intersect at? 4, 2. Good job. So that is your solution. So think you can handle that by using a table and using a graph? Obviously, the table takes more time. And I know manually graphing these takes more time than GeoGebra. The last thing I want you to do is get down what this is. Okay? Basically, what you need to do is make sure you get down these pictures, because these are the important things. A system that is consistent has at least one solution. So basically, a system that is consistent, you will be able to solve the equation. A system that is inconsistent has no solutions. A system can be independent, in which case there is exactly one solution. And a system can be dependent, in which there's an infinite number of solutions. And so what you need to get down is that a consistent and an independent system of equations looks like that. It will have two intersecting lines with one solution. A system that is consistent and dependent means that you will get the same line twice. And so you're going to have an infinite number of solutions. And an inconsistent system of equations is a system of equations in which you get two parallel lines. And remember, parallel lines never intersect, so there's going to be no solution to that system. So I'm going to let you abbreviate these because I know it is kind of a pain to write that on your homework. This is what my students in the past used to call them. Consistent and independent was C and I. Consistent and dependent was C and D. And inconsistent was I. But what you need to get down is a picture, a mental picture of each of these three. Consistent and independent. Remember, two lines that intersect in one point. Consistent and dependent, the same line that you've graphed twice. And then inconsistent is two parallel lines. So with that in mind, I want you to think back to the 4 previous problems we had. What would those be considered in this classification? Consistent and independent, exactly right, because each problem of the 4 ones we looked at had one solution. Okay, now we're going to go ahead and stop there because that's where I stopped for the first class.
1 second.
And I'm going to go ahead and give you what your assignment is. Okay? And your assignment is going to be found on page 142. It's going to be 28 through 38, the evens.